Listo.
Ok. Hola a todos, bienvenidos a una nueva sesión de nuestras transmisiones en vivo del Chip Nicaragua. Esta sesión va a ser en inglés, así que me cambio a inglés. Um, we're going to be talking today with Rogelio Roberti. He is the founder of the OJP project, which is the proxy for Java and databases. He's going to explain a lot better than me right now. But Rogelio has been working on development for a lot of time now. He's from Brazil and now he lives in Ireland. And he's been, I don't have much words to describe it, but he's a very knowledgeable. I'm sorry, my English is not sometimes not that big, but he's a very knowledgeable developer and entrepreneur, I will say now, Rogelio.
Hello, everyone. Buenas noches. So my Spanish is not that good, but I'm happy to be here. Happy to be presenting to the JUG Nicaragua. And thanks for joining, guys.
Yeah, your Spanish is as good as my English, so.
I think your English is better than my Spanish.
So, okay, screen is all yours. Go ahead. I'll leave. I'll be behind. Any comments, I'll let you know, and be welcome. And go ahead.
Thank you very much. Appreciate it, Francisco. And again, good evening and good afternoon for you guys. Here is midnight and 7 minutes now. So I'm the founder, right, of J Proxy. I'll just share my screen here because then we get the presentation going and we have some structure. Let me just, can you enable the sharing option there, please? Guys, it's telling me that it's disabled at the moment.
Yeah, one sec. I'm checking that. This actually says you should be able to share screen. Share docs, share notes,
Ready. Done.
compartir.
Now it allowed. Yeah, Grant.
There you go.
Yeah, just let me know when you can see it.
I'm able to see it.
Yeah, proxy power there. Like this is the title of presentation, right? The presentation. So boosting your Java app performance with J Proxy, right? So let's start there by let me know when you can see it.
I'm able to see it.
Yeah, proxy power there. There is some sound coming back. I don't know if there is some change there. Like just testing 1, 2, 3. Now it's good. Can you still hear me, Francisco?
I can.
Great, yeah. Now we're in sync because there was some echo of my own voice coming back. Now it's all good. So this is what we're going to be talking about. I'm not going to go through the items, like we're going to go through them in the presentation. There is a small legal notice here. Basically, it says that this presentation is free for everyone to use. If you want to use the entire presentation or parts of it, you're free to do so. Just I'm not responsible for you, the way you use it or how you present it. Okay, that's the only thing. And you need to mention the project, right? So if you take any ideas from this presentation and you mention somewhere else, please do quote the project, right? Because that's how we get the word out. So a little bit about myself, not gonna spend too much time here, but I'm a father of 2 boys, all right? That's my main job at the moment, beside the open source initiative. I'm postgraduated in software engineer by the PUC Paraná, the Catholic University of Paraná in Brazil. Been working on software engineering for the past 18 years, worked for companies like MasterCard, Huawei, Citibank, Bank of America, currently working in Bank of Ireland. So I hold a few certifications related to Java and TOGAF. I'm the author of the design pattern proposal for autoscaling stateful systems in InfoQ. So if you're interested on topics like how to autoscale stateful systems. Like that's an interesting article to look into for sure. And I'm a blue belt in Brazilian Jiu-Jitsu. That's my hobby. So when I have some time, I try to get to the mats and do some rolling. These are our partners, our current partners, like people that started with us that helped a lot in the project. So the Comunidade Brasil Jug and the Switcher API open source project were fundamental for the OJP project to start. So I always mention them.
Rogelio, I interrupt. You have this window at the bottom with the Zoom.
Oh, with your name. I thought I was the only one that could see it.
Yeah, I can see it too. And it's on the video.
Let me see. I'll try to close it. Do you think I can close it? Let's see.
Yeah.
Are you still there?
No, I'm there. I'm here.
Yeah, because I was afraid to close that because I thought I was the only one that could see it. I thought you would close the call, but okay, great, it didn't.
Yeah.
So, yeah, go ahead.
I say thank you.
So before we start talking about OpenJ Proxy, I just want to make a refresh for you guys in relation to one thing that sometimes we as software engineers forget, that we work with limited amount of CPUs, right? And what that causes is that oftentimes serializing requests beats parallelizing them. And the reason for that is that, let's say you have a server with 16 cores, right? Or 20 cores or 32. The very maximum amount of real concurrency you have in that server is the amount of cores, right? So if you have, let's say, an 8-core server and you're trying to parallelize like 100 threads, that means that those 8 cores will have to switch between threads, right? And that takes time and effort. And basically what that means is that it needs to save the state of one thread in memory, load the state of another thread, execute parts of it, commands in the new thread, and then switch to the other, you know? So basically your CPU is doing that juggling of threads, right? And that loses time at the end of the day. By that, I don't mean that you can, let's say you have 8 cores, you can only have 8 threads, because we know that there are wait times. For example, when you're reading the hard disk, there is a wait moment there that you can safely switch between threads. And even though you spend time doing that, the overall performance is increased because you would be waiting anyway. So that's an important thing to remember. Like serialization commonly beats parallelization. And that's a concept we will keep in mind when we are talking about OpenJ Proxy and one of the rationales for it. So going forward, right, very good, a very simple example here in terms of how one of the biggest problems we have nowadays in relation to microservices and lambdas is that we can scale these applications elastic, right? So we can start with 1, 2 instances and then scale to 10, 12, 20, right? And normally, a very common scenario is that we use Spring Boot, right, with our Hikari CP connection pool inside of it. By default, is 10 connections. That's why I use 10 connections there. And we start, like running our application. In this example, is a very simple example. Let's say we were running one instance of the app, 10 connections to the database. The database is happy, right? 10 connections is easy to handle. But now your loads start increasing, right? You start getting more orders. Like someday, maybe some celebrity post about your app, and the number of orders start increasing, and your auto scale kicks in, and your Spring Boot starts spinning off new instances, right? So from 10 connections, we are up to 30 already, right? And the database starts to get worried about it, right? Because it's triple already. If we keep going, right, let's say it's Neymar post about your product, you're selling a lot, and it's Black Friday, and you're getting a lot of orders. And now your app is at 5 instances. There is 50 connections hitting the database, and the database is under stress already, right? Like it's not a normal day. And in our example here, you hit eight instances of our application, 80 connections. this database was sized for a much smaller amount. Like in normal days, you would be working with maximum 20, 30 connections, and today there is 80, hammering it, producing what we call a connection storm, right? And this connection storm oftentimes render the database unavailable. So how can we sort this? Because you see, we have a connection pool inside the app, and each connection pool has its limits. Let's say it starts with 5 connections, but it can go to 10, or it could be even more. This example, I put 10 connections maximum. But oftentimes applications are configured to go to 20, 30 connections. Depends on the size of the application, really, and how many instances you plan to have in normal days. But we are not talking about normal days here. We are talking about days when your app goes under stress. And that's an important aspect of OpenJ Proxy. We produced it to work under stress, not in normal days. Because in normal days, in the easy days, any architecture works, right? Like you don't need to do any fancy things to produce something that gets a few orders a day. But you do need to produce good engineering when you're talking about days that you have an increase on scale very fast, very quickly, right? So our database is dead there. Like, let's go to the questions we aim to answer, right, with OpenJ Proxy. I was talking to the guys, like, if you have questions like that, you feel like, oh, I didn't understand this, or I'd like to understand it better, please interrupt. I can stop and answer questions during the talk, no problem at all. Feel free to send in the chat or in the comments. I think we're live on YouTube as well, or in Facebook, I heard as well. So, and the guys will convey the questions. So, but the questions I made myself when I was thinking about creating the project were these ones, right? Like, how can we elastic scale our apps without overwhelming our databases? So avoiding the problem we just described, right? How can we make this compatible with many databases and many cloud solutions? Because we do have other proxies, right? We have the AWS proxy, for instance. It's basically the same thing as OpenJ Proxy. But the difference is that it only works in AWS. And that's a problem, right? Because you're basically bound to the cloud then. You're using a solution that's for that cloud and only works in that cloud. Or you have in the other side, the PG Bouncer, which is for Postgres, right? It's a popular proxy for Postgres. But same again, like you have one proxy that works only for Postgres. So if you have different database, what you're going to do? You're going to be using different proxies. Then you need to manage all that, and they are different. And I thought we could do it better, that we could do it in a Java way. And the Java way is freedom, right? I think a strong word in Java has been always freedom. And we like to be free to use what we want and to switch if we need to. So also, how can we deliver seamless integrations with Java apps, right? Like we don't want to rewrite our apps to use a new proxy. That's important. How can we make it more open source than the existing solutions? Like if we look at the AWS proxy, or like there is a Cman from Oracle, they're good solutions, no doubt, but they are locked into one provider, right? And like the code is not open, especially Oracle. It's not open source. So I see that as a problem, like because again, you're binding yourself to one provider, and that can bite you back at some point. Can we develop this proxy in Java? That was a question, right? Like, is it worth to develop a proxy in Java? Because most of these proxies, they are built in the language that the database is built, which is most of the time C, C++, like there is many proxies built on those languages. So I wanted to experiment with, like, let's build it in Java. Let's see how it performs. And can we have a connection pool that is as efficient as Hikari CP? Because Hikari CP is a well-known and trusted connection pool in the Java community. Is the default connection pool of Spring Boot, right? Not for no reason, right? It's considered by many, arguably, the best connection pool in the market. So can we have a connection pool as good as Hikari CP in OpenJ Proxy? So And then this design came about, right? So this kind of answers all those questions. So what if we develop our own version of a JDBC driver, right? That sorts the problem of how can we integrate with Java apps? Because by providing a JDBC driver, what that means is that you can just switch your driver to our driver and everything should work. We also provide a proxy server, right? So the OJP proxy server, and that's a server separated from your app that holds a Hikari CP connection pool. So instead of asking ourselves, like, can we build a connection pool as good as Hikari CP? The answer was, why not use Hikari CP? If we are writing in Java, we can simply use it, right? So OpenJ Proxy is the union of three giants, right? The first giant is the JDBC specification, right? We provide a JDBC driver, so you don't need to change your whole application to use OpenJ Proxy. You just switch your driver to ours, and it will connect to our OJP proxy server. You need to change a little bit your connection URL. We're going to see it later. But that's about it. Like you don't need to change a whole lot in your app to start using OJP. And that's important, right? Because compatibility and pluggability is very important for adoption. The second big aspect of OJP is we use Hikari CP, right? So we just got the arguably the best connection pool that there was in the market, and we put in our server. That doesn't prevent us in the future to put other connection pools, because it's open source, really. You could even switch it to your own preferred connection pool, but it comes with Hikari CP mainly because Spring Boot comes with it, and the Java community, trust and love Hikari CP for a long time now. That was the full choice then. So that's the second big pillar of OpenJ Proxy, right? And the third one is the gRPC protocol. You see there in the picture. The gRPC protocol is a protocol that operates in HTTP 2.0, right? So it uses the multiplexed channels that HTTP 2.0 provides. What that means in short and in easier words to understand is that it's very fast and very efficient, right? To communicate data. So what we do is that our JDBC driver communicates with our OJP server via gRPC, and then the OJP proxy server communicates with the database over standard TCP, right, with using the JDBC driver of the database you're using. In this case, in our example, let's say you use 3 different databases, which is uncommon, right? Usually people use 1 or 2 different databases. But let's say you could do that with OJP. You could have OJP managing 3 different connection pools to 3 different databases. And you can see there that the apps are sending 30 connections into OJP server, but the database is getting only 10. That's because we virtualize connections. So the connections that the app get is not a bound connection to the database. So just by doing that, we already alleviate the pressure in the database. And so we work as a backpressure mechanism, right? So the database will always receive a steady flow of requests. It's never going to be overwhelmed. That's why our symbol is a shield, because we are a shield to the database. Because the database cannot scale as fast as the app, right? You can scale your apps very fast. And in clouds, you can auto-scale the database as well. There is configurations for that. But usually when you configure that, what you're really doing, what the cloud is really doing, is basically over-provisioning your database, right? That's what it's doing, and it's charging you for that. Because if you have the time to read my article about auto-scaling stateful systems, one of the challenges of auto-scaling a stateful system like a database is moving data. So you cannot just spin up a new instance of a database. You need to move the data and get that node warmed up, right? So what the clouds you probably do under the hood, because they don't disclose exactly how they do it, that's why I wrote the article, is that they pre-warm that node, right? But that has a cost. So if you're using auto-scale databases in cloud, you're paying probably for 1 extra node or 2, under the hood. So that's the reality. So with OJP, you can be safer in relation to knowing that your database capacity will be respected when you scale out your application. The flow to the database will be managed. And because what we talked about serializing requests oftentimes beats parallelizing them. In our preliminary performance tests, OJP performs oftentimes better than direct connections, because it serializes the requests to the database and organizes them in a more efficient way. Going forward, that's the picture then. The same picture as before. You can have your 80 connections hitting OJP, right? OJP will manage and organize them and serialize them into 20 hard connections to the database. And our database is happy again, right? So the database will always be capable of coping with this amount of connections. There is other problems, database-related problems, like you can have a poison query or things like that. And we're going to talk about that in a moment. We created solutions for that. But in terms of concurrency, like problems caused by excessive concurrency reheating the database, OJP immediately give you a backpressure mechanism that will defend your database against this pressure and make your database happy again. One thing that is relevant to talk about here is what we call the distributed monoliths, right? Some people don't like to talk about it, but it's the reality of many companies. And in our OpenJ Proxy meetings, talking to developers, it came up many times. So I wrote an article about it. If you're interested on the full article, it's a very short article, but that talks about this. It has this picture in the OpenJ Proxy page on LinkedIn. You can access it there. But in short, is that situation where you start a migration from a monolith to microservices, right? And you start with all the best intentions. You want separate concerns. You do your domain-driven design, and you go splitting up your monolith into microservices. And let's say you get your orders, billing, inventory, microservices there. But when you start talking about splitting the data, then in many cases, it doesn't make sense, or it's not economically or timely appropriate to split the database, to have one database per microservices, for instance. So what end up happening in many scenarios is that you have your microservices, you have your microservices separated by domain-bound contexts like orders, billing, inventory, but you still have a single database, right? And you see where I'm going with that, right? Again, you have many apps hitting the same database. And again, OJP is a perfect tool to manage that better. So I think we need to also look at the reality of companies, right? Because not all companies will be able to produce an architecture that is, a purist microservice architecture. Many companies will end up with the distributed monolith kind of architecture, where you have your microservices separated, but you still have a single database cluster. And in those situations, OJP is a wonderful tool for the reasons we discussed so far. It will shield your database, will create limits for these apps in relation to how many connections they can open, and will defend the database against sudden connection storms. Because in this scenario, again, like let's say the same scenario we said before, for some reason you start selling a lot, your orders microservices start scaling up, and you have all these microservices hitting the database. And then in the billing department, someone issues a report, at the same time. So we're going to talk a bit about, slow queries versus fast queries as well. We created a design for that scenario. But, this pressure, if you have all the apps connecting directly to the database, again, you may render your database too slow and you start losing orders, because that's the worst scenario, right? Like in the best day of the year that you're getting loads of orders, your database gets too slow, starts timing out queries, it doesn't respond well, you start losing orders, the customer experience falls to the ground, right? Because everyone is trying to buy from your website or your portal. and they cannot. I'm using these examples of orders, and that's just as a common example, but anything really, right? It would apply. You probably worked in situations, if you have some experience similar to this, right? And these situations can happen quite easily. Now, why would we create a new proxy, right? So we need to have a strong reason to create a new proxy, because you see there in this Cartesian diagram, there's plenty of proxies out there, and I didn't even mention a few here, like Oracle. Cman is not even here. There is a few others that are not here, but just using a few famous ones, we can see in this diagram the reason why OJP has to exist, right? And it had to be created. In the vertical axis, you see their database agnosticism. What that means is that how many different databases does the proxy support? So we can see there that Proxy SQL and MaxScale supports a few more databases. I believe they support mostly MySQL family, so MySQL, MariaDB. I think they might support Postgres as well, if I'm not mistaken. And if they're blue, they're open source, right? So we do have proxies that are open source. You see the blue ones there? They are open source. And they are more to the right because that's how much open source they are. Because sometimes you have something that is open source, or is partially open source, or is under a non-permissive open source license, right? Because maybe the license is not that permissive, so you cannot do much with the code without giving it back. Like you can have restrictions on the license. So the OpenJ proxy is the only proxy that exists today that's fully open source. We use Apache 2.0, right? A very permissive license. Basically, you can do whatever you want with the code. You can rename it. You just need to mention that you use OJP as a base, right? That's basically the rule. Like as soon as you say like, oh, I started with the OpenJ proxy and I build my own proxy, you're free to do. You can do whatever you want with the code. The code is free to use, no charges attached, fully open source, fully published in GitHub. You can access it, you can fork it, you can do whatever you want. That's why OpenJ proxy is the only one that gets 10 points on this, because none of these proxies that are in this graph are fully open source. If they are open source, they use licenses that are not as permissive as Apache 2.0, right? In the beginning, we thought about using MIT, but MIT and Apache 2.0, they're very similar in how permissive they are. We ended up with Apache 2.0 just for convenience, because in the future, maybe we might even put OJP under the Apache umbrella or apply to do that. So we love the open source idea. We want OJP to be free forever and open source forever. That's the idea. And we see that the red ones are proprietary. So you have there ScaleArc, Amazon, Aurora Proxy, right? And then you have this squared and dotted that they're partially open source, but they're tied to a specific cloud, like Google Cloud Proxy or Alibaba Proxy. So again, like it wouldn't be easy to switch if you have to, right? So the only proxy in the market that is fully open source and fully database agnostic, which means it supports many databases. We currently test 8 different databases in our CI pipeline. But in theory, OJP, because it uses JDBC drivers, it can support any database that supports a JDBC driver, right? That's the main thing. Any questions there? I'll just make a quick pause here just to see if there are any questions. If not, we can continue.
We just have greetings. Here's Giovanni from Barranquilla that says hello. There's Jessa from Nicaragua that says hello, but we have no questions for them.
Okay, so I must be explaining it very well. So no questions so far. If any questions come along, you can interrupt me and I'll stop, because I speak a lot. So please do interrupt me and I'll answer any questions. Yeah, so basically what we've been talking about, these differences, right? OJP versus existing proxies. I think one of the biggest differences is written in Java, right? I think Java developers, we like things written in Java. That's it, because we are Java developers. And that gives us the confidence that if we don't like something in an open source project, we can see and look at the code, right? Like, even though we don't do it frequently, I've done it a few times. Sometimes you need to go into the code and find something, maybe report a bug on a library or something. So we are more confident to use something that's built in Java. Because it's built in Java, is a layer 7 proxy, right? So we build it at the application level. And that gives us a level of abstraction that allow us to do a lot more than other proxies, right? Proxies that operate more at the network level, it's harder for them to put more intelligence in the proxy, right? Because OJP, even though the name is proxy, it is really almost an application on itself, right? Because it has intelligence. It doesn't just proxy the connections as we spoke. It only allocate connections when they are really needed. So let's say you create your connection, you're setting your parameters in your prepared statement. Not you, right? Your JPA is doing that for you. But under the hood, JPA is using JDBC to do that. So using OJP, when it only going to allocate a connection when you actually execute that query. You're not going to allocate before. And you don't have that guarantee with JDBC drivers from the vendor or even with these proxies, right? So you can add this extra layer of intelligence. So just allocate the connection when it's really needed. Be like, if I'm setting the query, if I'm setting the parameters, I don't need a connection, right? Basically, that's it. So you only allocate when you need. We already talked about database agnosticism, cloud agnosticism. OJP can be deployed in any cloud. We have a Docker image, right? So you can deploy in any cloud. You can deploy on Kubernetes quite easily. We have some scripts to do that. And you can deploy it as a jar. If you're deploying bare metal, you want to deploy yourself. We have documentation on how you produce your runnable jar, and you can deploy it as a jar, no problem. It's not just for Java, even though we're going to be talking a lot about Java here, because we use gRPC protobufers API. gRPC is not only for Java, right? It can be compiled into Python, C, C++, C Sharp, Golang. Basically, in theory, you can use OJP with any language that compiles protobuffers. You just need to implement the API. Now, that is a good bit of work, okay? So I'm not going to say that it would be easy. Depending on how you want to use it, or for how many components or, let's say, parts of it you want to use, it might be useful to do that. But in the future, what we did with the JDBC driver, we want to do with other languages, right? So we probably, once the project grows, we want to start other clients like ADO.NET, for example, maybe a Python client, a Golang client. So we want to start these other open source projects for different clients for OJP. So that's a nice thing as well. It's not bound only to Java. If you use other languages, you can connect to OJP with some work at the moment, and maybe in the future, even with dedicated drivers for it. So for Java apps, it's frictionless, right? Because we provide a JDBC driver, so it should be very easy to integrate. And it's unprecedented freedom in the proxy space. As you saw in the previous diagram here, like OJP is the only real freedom based proxy, right? Like, we are very careful how we build it. So you can use with any database, any cloud, even in any language, and it's fully open source. There is nothing like that in the market. The OJP is the first, and that's why it had to exist. Like, if nobody did that, we had to do it. Like, let's bring it to life. This is our API. So you see that now it's a bit bigger than that, because we are currently creating the extended, the distributed transaction capability. So we have more methods than this, but this is the basic API that we created. You see that's much simpler than JDBC actually, because JDBC is a core fundamental API in the Java world, right? But it's quite old now, and in some places it has too many interfaces, right? Because it was created at a time that, for example, we didn't know we would have microservices when JDBC was created, right? So it was not created for the world we live in today. So there is many interfaces that if they were written today, they probably would look more like this than what JDBC looks like. So basically, you have your connector, execute update, execute query, because if you're executing an update, you just get the number of rows updated, right? If you're executing a query, the result is your result set, right? So you can also fetch more rows, for pagination, create lobs, large objects, right? Because you need to treat them separated than other things. So you creating and reading lobs. You have a method that terminate your session, right? Basically closing everything down. And transactions, right? Like you can start transactions, commit, rollback, and the call resource is the fallback. So anything that don't fit in the other methods, you can call a JDBC driver resource. Let's say you want to get the metadata of the database. So you can call that into the appropriate resource in the connection, get the metadata, and it will come back as a result, a core resource response. So anything that is not in those APIs that we defined and that you want to use from JDBC driver, you can call through the call resource option there. Here's just, yeah, go ahead.
We have 2 questions. First one from Jaime Cruz. He says, only can connect to one type of data. If the proxy can connect only to one type of database at the same time.
Very good question. It can connect to many databases at the same time. You can define many different connection pools, and you can connect to more than one database at the same time. It's not restricted to one. You can even connect, you can have more than one connection pool to the same database as well. So if we go back a little bit to this, that example there, right? So if you have 3 databases, right? Oracle, MySQL, and Postgres, you can have 3 different configurations for connection pools, and it will connect to the 3 database drivers. The only difference here between the MySQL and Postgres is that if you're using Oracle or any other proprietary database, you need to put the JDBC driver that you use inside OJP server, right? And that's because of licensing. We cannot pack the OJP server with proprietary drivers, right? It's just a legal problem. But we do pack with the open source ones. So if you're using MySQL or Postgres, it's already packed with the OJP server. Now, if you're using Oracle, you would have to, but basically what you need to do is you need to put the Maven dependency in OJP server so that the driver is there, because the code is already there to use Oracle, to use DB2 SQL Server. Those are the ones supported, the proprietary that we tested and support more closely. But in theory, like I said, as soon as a database has a JDBC driver, in theory, you should be able to use in the OJP server. So no, it's not bound to one database, and you can have more than one connection pool to the same database as well. Okay. Hope that answers.
Yeah, I think it does, but we'll see. We'll let you know if Jaime has another question.
Oh, please do. Yeah, keep them flowing. If you feel like, oh, I didn't understand this, like I'd like more info. That was a very good question. Yeah, because it's very important really to know if you can connect to more than one database. It's a common scenario. Like I worked in companies that, for example, for their main applications, they would use Oracle. But then for their more experimental applications, they would use Postgres, right? So it's very important to be able to connect to different databases with the same tool. It's a very good question. Thank you. Thank you for that. So again, yeah, go ahead.
It says, Armando Alani says, is it possible to use this proxy to determine if the proper size of a connection pool?
No, but I have the right tool for you. It's called FlexiPool. FlexiPool is a library that you install in your It's from a Java champion that is, it's Vlad. Vlad is his name. Is a known Java champion, and I've been in contact with him, and we might integrate that into OJP. We are in conversations of maybe integrating that. What FlexiPool does is that you cannot use it you should not use it in production. What it does, it instruments your connection pool and evaluates if you're using the best metrics, right? In my view, in my experience, the only way to find the right number of connections you need is to get a good prediction of what is the maximum amount of load you want to be able to support in production, and then test it with different parameters, right? Let's say the maximum load in production that you want to be able to hold is 100 transactions per second. That's massive, right? That is like massive amount of transactions. Let's decrease that a bit. Let's say it's 10 transactions per second, right? So you should create a test, a performance test with those numbers, and then perform the same test with different parameters, right? And don't be surprised if you perform better with less connections, because I've seen it many, many times. Sometimes you decrease the connections and you get more throughput, because what we talked about, like switching context, right? Switching context between threads is expensive. So if the database needs to be handling the parallelism of 100 different connections, it spends time switching between connections and managing those connections. And that time and effort could be used, doing database work, which is saving and retrieving data mostly, right? So when you oftentimes you reduce the number of connections and you get more throughput. That's a common thing. So the advice I would give you is that, like, get the best test you can, because we cannot predict everything in production, right? Let's just be clear about that. But we always have, we can make informed decisions or predict our load, right? The best we can. It's usually not account for Neymar posting about your product, but or you being under a DOS attack, right? Because that's another scenario that OJP helps with. Because if you have this back pressure mechanism, and OJP is one of the tools for that, you also withstand better if you're under a DOS attack. Just reminding everyone what a DOS attack is: the denial of service, right? Like when someone purposely sends a huge amount of requests to your application, and the application eventually cannot handle it anymore and is rendered it goes down, right? It's rendered unresponsive. In many cases on DOS attacks, the database goes down. So with OJP, I would tell you that the database would never go down. And OJP probably wouldn't go down either. What you would end up seeing if it's a large DOS attack is that your app eventually would start timing out, right? Because eventually you're not going to be able to acquire connections to the database in time, and it's going to time out parts of the requests, but it's still going to be processing some of the requests. That would be the difference between using back pressure mechanism like OJP and not using it. It's not the only tool to use for. I'm not saying here that you prevent DOS attacks with OJP, not at all. If you study how to prevent it, you learn that you can never fully prevent it, but by adding these back pressure mechanisms, you can mitigate it, right? And OJP is surely a good tool to help with that. Now, another nice implementation we did quite in the early days, like our first performance tests on OJP showed that if you have a query that is, let's say, average heavy, but that's consistently failing, that puts pressure in the database that didn't need to be there, right? So the idea of creating a circuit breaker into the proxy came about. Very simple idea, right? So basically what a circuit breaker, not just in OJP, right, but any circuit breaker will do, so when it fails consistently, you stop the flow, right? So like in this example here, let's say all queries are flowing nicely to the database, so the proxy is just, let them pass through. And each line here is not a connection anymore. Each line here represents a different query, right? Like you have a select query, an insert query, an update query, etc., etc., etc. So if they're all performing fine, they are not broken, they are not failing, the proxy keeps sending them to the database. Now, what if a query starts failing repeatedly, right? And I can give you an example that happened to me in the past, that there was a situation where a value in the database was not expected to be 0. But in a certain scenario, it eventually became 0. And, it produced a division by 0 error. And it was a bug, obviously. It took forever to find out that was the bug. But that query would always fail. Like it wouldn't ever succeed, but it was always hammering the database and taking a substantial amount of effort from the database to produce the result. So what we did with OJP by implementing this circuit breaker is that OJP will monitor every query, right? And how many times that query fails. So every query you do against the database is monitored. And if it fails by default 3 times, but you can configure it differently if you want. If it fails more than 3 times, OJP will block it, right? And you're not going to send that query to the database anymore. So when the Java app sends that query in, we know it's failing consistently, right? Because it failed more than 3 times now. So we just send the same error back to the app. We don't send it to the database. And that, saves the database a bit of effort or a lot of effort, depending on how heavy that query was. Now, after a while, by default, we leave 1 minute. So after a minute, OJP will try 1 time the same query that was failing. And if that query succeed, it's going to go back to green, right? It's going to go back to sending the query to the database. If that 1 time that it tries the query fails, it's going to open again the security breaker and going to block it again. So that's a very nice feature that we did because it produced a substantial improvement in performance. When these queries, we did some testing that is in our CI/CD pipeline now in relation to sending many queries and poisoning 1 query with a division by 0. So that query will always fail. We know that it's going to always fail. And then we measure differences between the performances. And it's massive. Like I can show you some of the numbers that we got, and it is just impressive. Going forward, so our performance test. So this is the first performance test we did. There is a newer one now that is in our LinkedIn page, an article about it, a newer one, even more robust test we did with more threads, with more situations. But this is a basic one. So basically, we had 2 droplets in DigitalOcean, right? 1 CPU each. So 1 to have the OJP server, 1 to have the database, Postgres running on Docker. So they're very small droplets in purpose because we wanted to stress them. So it's easier to stress something that's small than to stress something that's big, right? 100 threads. So we built this custom test, integration test that runs multiple threads. So 100 tests is the minute, is the concurrency. And the run-up time is 1 minute. So 100 threads in 1 minute. Each thread executes 67 statements, so a mix of select, joins, updates, etc. And there is 1 failed query, right? There is 1 query there that we poison with a division by 0. So it's a query that does a couple of joins and there is a division by 0. So it's going to always fail, right? But before he fails, he's going to spend some work of the database. So that was the intention, like to measure what would be the difference, if you keep sending this poison query versus if you don't send. And obviously with the back pressure of OJP managing connections more efficiently. So the focus of the test, yeah, go ahead.
I have a couple of questions more. Sorry to keep interrupting, but Sergio Sanchez asks, what are the key techniques or features that J Proxy uses to increase the performance of Java application? Example, improving resource management, stability, or scalability.
So it helps with the scalability, right? Because you can scale your apps more safely because you know that your connection pool will be controlled. Because if you don't have a proxy like OJP and you have, let's say, your app running in Kubernetes, and you put there in Kubernetes that you can scale from 2 to 20 instances, and your connection pool in each of the instances can grow up to 20 connections. If you reach the maximum capacity of your app at 20 instances with 20 connections each, that's 400 connections, right? So if you don't have something like a Open J Proxy, like you cannot do that really. You need to reduce that to maybe 5 maximum. You need to reduce your scalability a lot, right? So just by putting OJP in, you increase your scalability quite a lot because OJP can handle a lot more connections efficiently. So again, you're not going to lose performance by reducing connections because of all the factors we already discussed. So the first one is scalability. The other one is reliability, right? Reliability, because OJP, as we spoke, creates this backpressure mechanism. So it makes your entire system more stable and more reliable. Because if you're under a lot of pressure, like we talked about in a DOS attack, OJP will help you to survive. Okay, so if you have this, you look that we care about many of the threats that usually bring the database down, right? Load the storm connections, poison queries. We try to cater for these scenarios where the database, when the database goes into so much pressure that eventually goes down, or it doesn't respond well, it responds too slow, start timing out. So reliability and scalability, I think, is the things that OJP helps the most. And it does that by implementing a backpressure mechanism, right? By not letting the pressure get to the database. So it holds the pressure like a shield. It does that by allocating connections in a smart way, not giving connections whenever the app asks for a connection. It does that by the circuit breaker, right? If you have poison queries, after 3 failures, we don't send that poison query to the database anymore. We hold that as well. And we have also something that we call this slow query segregation mechanism that I'm going to talk about in a moment. So these are the ways we currently help your application to perform better. And we're going to see some numbers here now of the test I just described. So what happened in that test was that we executed 6,700 queries, okay? So the comparison is between using OJP and using JDBC connections alone, so without any pool, right? So let's say that would be a comparison if you're using lambdas, right, without a proxy, because lambdas cannot have a connection pool, because lambdas can turn off, right? So a lambda can be on or off. If there is no use for a certain app, the lambda will basically stop and we will only start again if there is a new request, right? So you cannot really have connections in lambdas. So that was the target of this test, to simulate like in a lambda scenario without using a proxy or using OJP. So the results were quite encouraging. Like on the right side there is the CPU usage of the database with OJP and with direct connections. You can see that it's massively different, how much OJP protects the database against the load. So without OJP, the database reached there like close to 70% of capacity of CPU, right? And if we put a few more threads, like we used 100, if we used like 120, 150, maybe we would have reached 100% of CPU capacity in the database. But the goal of this test was not to break the database, was just to use something that just before it breaks, just to see really the differences in speed and performance and in resource usage in the database, especially CPU. The focus of this test was CPU. So it proved that OJP saves a lot of effort from the database. But the most staggering, the most surprising things for me were really the speeds, right? So the test duration using OJP, it took 64 seconds, right? So the test ramp up was 1 minute. So it took 1 minute and 4 seconds to completely finish the 6,700 queries. without OJP, opening connections, directly with the database in a fashion that lambdas would do without a proxy, it took 80 seconds. So a big increase, right, on how long it takes to finish. And that's related to the database needs to manage all these connections, right? So it doesn't do the work that it should be doing, and it takes longer to finish them off. So average duration, query duration, like is 40%, more than 40% faster, right, using OJP. And query failures, 100 query failures for each, because remember, we had one query that we failed in purpose, right? So, and that query is a major accountant for why OJP is so much faster, so much more efficient, because if you don't have OJP, and I don't think you have any proxy that does this circuit breaking, at least not in the way that we do. In the research I've done, if someone knows a proxy that does circuit breaking, let me know, because that would be news for me. But usually the proxy only do proxying, right? It doesn't do these smart things. It doesn't try to. There is some other smart things that other proxies do, but they don't do these things that I think as Java developers we feel that these proxies should be doing. Max CPU used in the database. So with OJP 14.8, that's maximum used, average 10.3, and without OJP 61% maximum and 41% average. Those were the differences in the first test we did. And yeah, we can do a quick demo. I hope it's quick. I saw that unfortunately the thing that I prepared was not really working before the presentation. So let's see if we can get it running. But
before we get to the demo, I have a couple of questions.
Yeah.
Isaac Perez says, does OGP introduce any noticeable latency between sending the request and the availability of the data in the database?
Because it adds a round trip, right? A network round trip. Is that your question? If it's lower because you have one more guy in the network, can you just elaborate on that?
Yeah, probably he's talking about that. I mean, since there is another subject in the middle, and it's gonna affect performance.
If by performance he means it improves performance, right? We just showed that under stress it improves performance. That like every time we put stress on the database, it improves performance. Now, if you're sending one request to the database of a query that doesn't, let's say you're sending a select one to the database, right? And you're testing it with.
Yeah. Rogelio, we have the other question is actually very related, so I'm just gonna throw it out so you can answer both.
Okay,
So
sure.
what specific performance gains in terms of latency, memory consumption, or throughput can be expected when using J Proxy in a typical application? So I guess those are related. So just wanted to throw them both.
Right. So those numbers that we were just showing, those are the like. I think what you can expect, it depends, right? Like I cannot promise you improvements in performance, but what we experienced, if we look at these numbers, is that if you have a load, and this is not a small load, right? In 1 minute of 100 threads, that's 100 users, let's say, that is equal to 67 queries each to the database in 1 minute, right? You could expect these improvements, okay? And you're not using a connection pool at all. Like you're using lambdas. Now, if you are using a connection pool, these differences will reduce, right? Because you're already using a connection pool. But that depends again on how many instances of your application you have. Because let's say you have a connection pool in the application, and you would have to tell me, like, you would have to change these parameters to the amount of connections you're using in your application, right? And test it. That's something we are interested in seeing, like that people get OJP and testing their applications and bring us the results that they are getting. I think this is an extreme example, right, that I'm showing here. I don't expect you to get these these improvements, especially in speed of queries. But I expect you to get especially the protection of the database, right? So what we notice is that every time we put some sort of a pressure in the database, OJP performs like amazingly better than without OJP. So if your database is suffering with the moments that it gets too slow, that gets too busy, starts timing out, or that you're afraid that that could happen, or maybe you're over provisioning your database. There is a common thing that people do, like because they are afraid that the database go down or it has gone down a few times already, they over provision the database. Sometimes there is companies operating, like especially big companies with big money, right? They operate with databases that their capacity sometimes is 10 times, 20 times their average consumption. And that's fine, they have all the money to do that. But I don't think that's the reality of many, and I don't think that's a smart way to do it. I think it's just a convenient way to do it, right? You spend the money, you buy the servers, and you have that extra capacity. What I think is a smarter way to do it is to use something like OJP and use a reduced database that is more fit for your average consumption. And then when you have those days that you have the extra incoming traffic, OJP will hold that off and will not let that cause you a trouble in the database. So the improvements in performance that we measured so far is in this article. There is another article about performance in our LinkedIn page you can look at. So the only way you get what performance you get in your application is by testing it in your application, okay? Like I cannot tell you that. What we experienced so far is that as more pressure we put in the database, as more problems we cause to the database, when we put OJP in front of it, it carries away a lot of those problems, and OJP could be the survival boat for your database. Like it's really the shield for your database. So it's a long answer to say, like, I don't know. Like, I don't know, because the scenarios are different, right? Like, so if you send one query to the database, that's the previous query, because you have a middleman, right? Does it slow down things? Yes. When does it slow down things? When you're sending a few queries, right? Like if you're sending like just a few queries to the database, then you don't need OJP, I would say. You don't need any proxy, right? If you're building an application for I don't know, your school or something that has very little access, that there is no chance that it's going to spike on demand at some point, I don't think you need it. It's surely going to put the extra round trip on network there. But now, if you're working with things that can go to thousands of orders or to millions, and you might face pressure, real pressure. So if you're developing an architecture for something that needs to operate under this kind of scenarios that includes more load, more pressure, OJP is surely a good fit, and it's a good thing to be trying out. We're currently in a beta version, right? So it's a testing version. We don't advocate yet for people to put in production in critical applications. But if you have a smaller application, an internal application that you would like to try it out, or try it in test environments, that's what we are looking for. That's why we are giving these presentations. We want people to get OJP, to try it, to test it, to put it in their testing pipelines, and come back with problems. Like any good feedback, bad feedback is welcome. We want to learn from the community, like what the community thinks about it. Like many of the ideas we implemented so far came from people that gave feedback, right? So people that we talked to, and we adapted OJP to their needs. So if you test and you see like, oh, this is not working well for me because of this and that, that's the kind of thing we want to learn at this phase of the project. Like it's a beta phase, so we need all the testing we can get, and all the people trying OJP. And that's not to say that it's not robust enough to use it in production. I would say that you could use it in production for non-critical applications, no problem. We have around 1,000 tests in our CI/CD pipeline. We test a lot of things in OJP. We stress it every time. So like we're very confident with the quality of what we're delivering. But we want to receive more feedback before we issue the 1.0.0 version. So this feedback comes from people like you that gets it, test it, put it to run. The feedback might be related to performance or related to how we document our things. Maybe it's not clear, needs updating. Also maybe related to or you could do it better in this way, that way. All feedbacks are welcome and appreciated. I hope I answered the question. So what we're gonna do now is a quick demo to show how you could put OJP in your app, right? So let me just go to the project here a second. This is our GitHub page, right? Don't forget to go there, star our project, and to watch it, fork it, just make sure you do it all. Because these stats are important for us. We need to grow them. And there are things like the Baodong website that we need to get a few more stars so we can publish in Baodong. Like I think they need 150 in total here. We are almost there. Like we're almost reaching there. We are going quite fast on stars on GitHub. You can see this graphic here. We are getting popular very fast. So if I did a comparison with other proxies project, like no proxy got this number of stars in such a short amount of time. So it's very encouraging. So please leave your star there as well. Like if you like the project, that's very important for us. Now here's the main page of the project, right? So at the very beginning here, like you can see our CI/CDs that all our tests are passing at the moment. So what tests are those? Like mostly integration tests against those databases that I mentioned. We also introduced a multi-node integration test now. This multi-node is clustering, right? So we have a test for that's not released yet. The is not in the version 0.2.0 beta. It's going to be in the 0.3.0 beta, which is the next one that should be released by the end of this year or beginning of next year. And it's going to allow you to use a cluster of OJP servers. So you're going to be able to use more than one, and you're going to get then the high availability, like a cluster of OJP servers, right? And if one go down, it automatically redirects traffic to another. This kind of thing is coming up. It's being tested at the moment in our main branch, and we have one of the big tests here. We also continuously test for Spring Boot, Micronaut, and Quarkus, and Spring Boot now with Atomicus integration, right? Atomicus for distributed transactions. So those are the integrations we support at the moment. Our license is Apache 2.0, right? Our Discord channel is here. If you want to join us and work closer with us, like we need all the help we can get, guys. So please do join if you can. So what do you need to do to get started with OJP? So the first thing you need to do, you need to run the OJP server, right? So let's, I usually run it in IntelliJ, but for the purpose of the demo, let's run it here. So you just need to have Docker, right? So you need to run, or Kubernetes, right? So once we have our OJP server running, which it is, here is the container, right? We gonna, oh, before we do that, actually, I'll just show you where I got the test from that I'm gonna be showing you. So we have two repositories here. So the OJP repository is the one that I'm showing you there. And there is this OJP framework integration. So the tests that I showed you there passing for Micronaut, Quarkus, Spring Boot, Atomicus, and Spring Boot, they are all here. So what these tests are, they are actually small applications written in each of these technologies, right? So if you enter here in Micronaut, for instance, what you're gonna see here is a Micronaut application, okay? So it's a shop service. It's always a shop service. Like we got this, because then you have orders, you have clients, you have reviews. It's a good example to use. So if we come here to the shop service application, you can see that, it's a Micronaut application. So they are small applications that we run CRUD tests mostly against H2 in-memory database, even though that Atomicus cannot be against H2, so he uses Postgres, right? Because H2 wouldn't support distributed transactions. So, but the other ones use just an in-memory database to test OJP, and they test OJP integrated, right? So they spin up, they do exactly what we are doing here. They spin up an OJP server, and then they run tests against it. So let's get the Spring Boot, which is the most popular framework used, and let's open the app here. So there is a bit of documentation here. You can see the APIs that are implemented in this little app. It's a web app, right, with an interface, so you can create users, CRUD operations. Apologies. Create products, orders, and reviews, and items, right? Order items. So very common scenario, right? So you can come here and see how it's configured. Obviously here it's configured to use OJP. So what I did, I got this guy open here in my machine, and I modified it to use Postgres, right? So instead of using OJP, that's how your project would look like, right? So it would look more or less like this. Now let me just I need to get the right, because I was changing the wrong. Yeah, I didn't clean enough. I should have cleaned. Just need to remove that. Okay. So we're going to be running one of the tests here, the user test. So basically what this does, it creates user, right? Deletes user, gets user. It's just an integration test that does a bit of CRUD operation. So, but it goes all the way, right? So it goes to the database, gets the data from the database. It's just JSON post requests. You're probably familiar with it. I'm not gonna focus on how the test is implemented. It's just post request, right, to a Spring Boot application. Now, currently this is using a JDBC driver that is the Postgres native driver, right? So we can see here it's using the Postgres driver, and there is no OJP yet here. So what there is one thing here okay, let me just, that's one thing we need to do for OJP. So let me remove that for the moment. So it's just a Spring Boot app, and we're gonna run this test for creation of user, right? Against Postgres, against H2 in-memory database. And it passes, right? So currently it connects directly to H2 database, right? So now we're going to follow the steps that we see there in the page to implement OJP on this, right? So like this is a scenario where you have your Spring Boot app. It's using currently the JDBC driver of Postgres, and we're going to replace it with OJP now. So if we come here and we look at the first page here, the next step we need to do here is to put our JDBC driver. Now, if you want more specific documentation on a specific, because in the first page here, we have the generic approach, right? So it's 3 steps, right? So you need to have your OJP server running somewhere. It can be Docker or it can be executable jar, right? And here's the guide for you to run it as a jar. You need to have the OJP JDBC driver in your app, and you need to change your URL. So these are the 3 basic steps. There is a few other steps that depending on the framework that you need to do. We're gonna talk about it. But these are the 3 basic things you need to do to run OJP. So you run your server, OJP server proxy, you put the dependency in your app. So you replace your JDBC driver, being that Postgres or MySQL or whatever it is, by the OJP JDBC driver, and you change your URL. The change in the URL is very simple, okay? The only thing that changes is that you need to tell your URL where the OJP server is. That's it, in the most basic configuration, right? So instead of JDBC column Postgres, you're going to use JDBC column OJP, and then in brackets, the location of your OJP server, right? So if you're running in the same machine, which is probably how you're gonna test it first, you're gonna start up in localhost, and the default port is 1059. And then close bracket underscore, and the connection URL continues in the same way as it was. You see here a few examples, like for Postgres, Oracle, SQL Server, always follows the same. It's just a prefix, right? You prefix your URL, and then the JDBC driver that you provided there will be able to read that and connect to the appropriate OJP server proxy. I said you can find a more comprehensive documentation about each framework in the documents here. So if you come here and you come to Java frameworks, you're going to see the same 3 steps again here explained. But if you go for Spring Boot, for example, then here's specifically how you do it in Spring Boot, right? So let's use this page instead of that, because that's a better page for it. So it doesn't talk about running the OJP server. It implies that you are already running it. So let's put our dependency first. So the first thing we're going to do here, we're going to put, we're going to remove the Postgres dependency, and we're going to put the OJDBC driver. Let's just reload the Maven project to make sure that it gets the version. Yeah, it figured it out. Now, in your Spring Boot starter JDBC, you need to exclude your connection pool. Why is that? That is because you're replacing your connection pool by OJP, right? So your connection pool is going to be in the OJP server. So you don't want a connection pool running in your application anymore. So you want to do this to exclude the HIC RCP that comes bundled with the Spring Boot. So that's a step for Spring Boot. And then here, you need to put a few configurations right into your application properties. The first one is the prefix, right? So we need to get this. And let's go to our application properties here. And wherever we see JDBC column, we put our prefix, right? We don't need to change this because we are running locally. So we have 2 data sources here. So that's not the most simplistic scenario already, because some applications will have just 1 data source. But we do have 2 data sources here. And we're going to be connecting to both of them, okay? So very simple username and password, right? Standard H2 is SA and empty, right? Another thing we're going to do, we're going to replace the JDBC driver, right? Because we removed Postgres, so we cannot use the driver anymore. So the class for the driver is changed. And the rest pretty much stays the same. Just once you remove in a Spring Boot, once you remove the HIC RCP connection pool, you need to put something in instead of it, right? So you do need to put the type for the data source, okay? So here, as we are using catalog, for example, like we have here catalog. So let me just put, needs to be the right data source. And we need to put that in this guy here as well. So we cannot have we don't have the connection pool anymore, so we just need to tell Spring Boot that you're going to be producing connections every time, right? So it's a simple driver data source. Now, because in this application we have more than 1 data source, we would have to produce OJP properties. Like if you have a single data source, you wouldn't even, you might not even need it if you want to use the HIC RCP default configuration. So, but because we have 2 data sources you need to produce an OJP properties. And that basically, I left one ready here. So we just can copy and paste, and I'll explain it so I don't need to type it all. What basically this is going to do is it has two data sources, right? And you can name and even name them differently than the ones you have in your Spring app. So this is to show that it's not bound to that. So this is the default one, which is not prefixed. You see, it always starts with OJP dot connection pool, right? So that the default connection pool will have a maximum pool size of 25, minimum of 2, and a connection timeout of 2 seconds, right? And then we have this high performance one, which will be minimum 10, maximum 50. So it's a bigger connection pool, right? And the connection timeout is a bit bigger as well. Now, because we have this different data source, we need to tell our OJP that's different, okay? So the only difference that it makes here is that we put the name here along with our OJP prefix, right? So that's how you name different data sources. If you're using just one data source, you see, you don't need to name it. It's gonna be picking the default one. Now, having done that, we should be good to go. So now we removed Postgres altogether, right? And the test here is basically just run that same test again, and hopefully it's gonna work, right? Because in these demos, sometimes things go south. Let's just see here. Obviously it failed. Let's just take a quick look here what happened. Connection factory. And let me just see the data source. You could not load the JDBC driver class. That is awkward. Could not find the class. That is weird because sometimes it's just cache on IntelliJ. You probably, if you use IntelliJ, because we did put the, let's double check, but we did put the dependency. So the dependency is there. That's all right. Let's rebuild the project just to refresh dependencies. Let's run it again. And that is, it's again not finding the class. It's just because it's a demo, you know, like this was working fine a bit before. Let's see. It's not really finding this driver. Why is that? The dependency. Did I put it in the wrong place, or? Let me just double check. And Spring Boot starter test. The dependencies here. External libraries. Let's just check if it loaded org dot. And then it didn't load the library for some reason. That's the issue. Yeah, I think it's IntelliJ cache. Sorry guys, like real quick here, I'll just invalidate and restart because it should be there, right? Like it's in the POM. We reloaded the libraries. It should be there. For some reason, it's not. So let's just try to refresh it here real quick. If that doesn't work, I'll just yeah, let's just give it a second to reindex. So if you use IntelliJ, you're probably familiar with these things. Sometimes when you switch libraries, it just doesn't pick up. This is also not a paid version of IntelliJ, so like I can't even complain much. So let's just give it a second. Still indexing, right? Let's see here. Because it should come up here. Yeah, it's there now. Yeah, that's a good sign. Yeah, it should be fine now. Yeah, that's nothing to do with OJP, right? It's just IntelliJ being nasty in a demo. Let's go with it. Yeah, good. Green is good, right? And to prove that we are passing through OJP, I'm just gonna kill it. Stop. And we should see an error, right? So just so we're sure that we were passing through OJP. So now it should fail to connect, right? Yeah, that is it. Yeah. Yeah, that's what I had prepared for the demo. Like you see, it's pretty simple to integrate. Like it's 3 steps really, if your IntelliJ allows you, right? But you're probably familiar with this. Sometimes things don't go as much. This is a contribution from some developers that tested. You know, like you might face some issues with the logging from Spring Boot, but it was resolved by this developer by just passing an extra Java opts here during running. I think he used a Windows machine, but I never had this problem. So that's a troubleshoot. That's the only problem we got reported in relation to running tests. Any questions? Any comments? If not, we're gonna continue, and I'm gonna speed up now because I think we are 1.5 hours in. I don't know how much time we have left. Are we good with time? Can we go a bit longer?
Yeah, well, I mean, you can take the time you need, but I guess I don't know. If you feel that you still need to explain things as your piece, just go ahead, don't worry.
Great. No, that's awesome because I can talk a lot. I mean, I could talk to the morning, but
Yeah.
but I understand that sometimes people want to do a certain timed version. I'm glad that we're free on time then.
Yeah, we
This
normally do some sessions here with JDK Fundamentals and normally take a couple of hours.
Yeah.
So, well,
Then we are within
Mhm.
still the couple of hours. Great. Yeah, I don't have a lot more slides, but I can explore more things in those slides. And this is something I'm very proud about OJP. It's a smarter version of a bookhead pattern, right? If you're familiar with bookhead is a pattern that we use to segregate things, right? So let's say you have like a bookhead in ships, right? So if you have anything of any type of resource, let's say threads or connection pools, and you create bookheads, you separate them, right? So like in the example I showed in the demo, where you have 2 different data sources. That's a type of bookhead, right? It's an implementation of bookhead because you're separating resources. In the main thing, it comes from ships, right? So a bookhead in a ship, it means that if the ship gets damaged, the exterior, you're gonna fill up one of the containers of the bookhead, and it's not gonna affect the others. So the same thing with the connection pools, for instance, or threads, right? And connection pools of threads. You can create different pools. So if one is under stress and is suffering, the other one is unaffected, right? So that it's a good concept. But the bookhead alone, it was not great for OJP, right? Because mainly because it's static, right? It's hard for you to predict the size of the bookhead. Let's say you want to split your connection pool into slow and fast queries. That's why we call it slow query segregation and not bulkhead. Because for us, it's about we want to split the queries by how fast they run. So we cannot predict it before running the app, right? So what we did here, we created a system that, or an algorithm that controls how fast the queries are running, right? And it's a very cheap algorithm as well. I'm not going to go into technical details, but there is an article about that as well in our LinkedIn page. So you can go into there and see how we made it cheaper, because you also cannot keep all these metrics in memory, right? Like you cannot keep all this, hold the last 1,000 averages or whatever. It would be very expensive. So we made it a smart way to make averages of query times, so we can know at runtime if a query is slow or fast. And the best way I found to explain this is why this is important is by using these pictures, right? So imagine you're in a highway, right? So you're in a highway and you have tractors and trucks, and they are all mixed up in the same highway. That's your connection pool, right? Without something like a slow segregation algorithm, or at least a bulkhead, the way we separate the connection pools there. Like your slow queries are competing with the fast queries, and you cannot guarantee that your fast queries are passing in front of the slow ones. Like there is a first in, first out, right? And that creates the danger of, at certain moments, you could have slow queries dominating the pool, right? Because like we said, we want less connections to the database. That's usually more efficient. But if you have less connections, and at some points of the day you have a lot of slow queries running, they could take up the whole pool, right? And hold off quick or faster queries behind. So creating a queue in the pool, right? Basically the picture we have there. So what we created is the slow query segregation. So we divide the pool into different lanes. So we call it slots, right? But in our example here of a highway, what that would produce is that you, like the same way when you go in a highway, you have the fast lanes and the slow lanes. So we create the same thing in the connection pool. So we by default, we keep 20% of the connection pool for slow queries and 80 for fast queries. You can change that by configuring, obviously, but that's the start setup. Now we use our smart and cheap way of measuring averages of queries, and we can figure out at runtime what is a slow query versus what is a fast query, and we put them in the right lanes. So what that produces is, even if we have a bunch of slow queries at some periods of the day, they're not gonna dominate the pool. They're never gonna dominate the pool, because the lanes are separated in the same pool, which this doesn't exist yet. This is a completely novel approach. Like I said, bulkhead exists, but bulkheads are static. They don't measure in real time what is slow and what's fast. And that's very important, because if you go from one application to another, slow and fast have different meanings, right? In some applications, maybe slow is 2 seconds. In other applications, slow is 10 seconds. In others, it's 30. In others, it's a minute. I've worked in all those scenarios. Like you get applications that do a lot of heavy reports. Reports take time, right? Complex queries. Sometimes you can wait a minute for a report, and it's not a problem, because that report is only generated every week or every month. It's not a problem to wait a few minutes for the report to generate. But those queries are heavy, and they take space in the pool, right? So if you don't dimension that properly, you could end up with your pool filled with slow queries that dominate it. If you're targeting a smaller pool, which we are saying that in a lot of cases is better, it's even easier to take over the pool. So it became evident that we needed something that prevented these slow queries from taking over the pool. This is our solution for it. It's a novel solution. I haven't seen anywhere else in any proxy or anywhere else yet. So this is our contribution to solve this problem. Another nice thing we did, they can borrow lanes, right? So let's say at one point of the day, you have a lot of fast queries, right? And not many slow queries, because it's not reporting time yet. It's not end of the day or end of the week. Whatever the situation is, you don't have a lot of slow queries. And you have empty lanes in this slow query slot, right? So if we get an example of 10 connections, right? And you start with the full configuration with 8 for fast queries and 2 for slow queries. What's going to happen, you have more for fast queries than slow. One of the queries from these slow lanes will be borrowed by the fast lanes. You cannot borrow all the lanes. You need to leave at least one lane free for each side, but you can borrow up to leaving only one lane. in the same way the other side, like if there is many slow queries and there is free lanes or free slots in the fast side, you can borrow it. That also doesn't exist in bookhead pattern, right? Just to make a reference of what are the difference between bookhead and what we did here. In bookhead is static, right? You define your bookheads and that's it. Like they're not gonna adapt in real time. So I think that's something very cool that we created that protects your database and your connection pool against scenarios that can happen, right? It's a scenario that can possibly happen. Cool, guys. If you have any questions, please shoot there. But I want to talk about a bit about of how you can contribute to the project and what we are looking for at the moment and what we expect going forward, right? If there is any questions, please interrupt me. So, like I said, the first thing you can do to help us, because we are all volunteers here, right? Like I have a day job. All the guys in the community have a day job. This is an open source project. We do it for the passion of doing something that we believe is better than what is in the market and that nobody else will do, right? So we took it up to do it ourselves. It's a volunteer work. We need your support. You can support in many ways. So these are the ways. First thing, start on GitHub, follow, fork the repository. All that increases our relevance in GitHub. Is very important for open source projects. Try it yourself, right? We talked about it. Just get it running. Face issues. If you face any issues, go to our Discord, say like, oh, this is not working for me. How can I solve? Other people that already tested will help you. We are very friendly and welcoming community. We are a small community at the moment. So if you want to participate in open source, it's the best way to join, because we started this project beginning of this year. I was talking to the guys before even the presentation started. But the idea is like from 2018. So the problem is from 2018. And then it took all these years to come to this solution and to start building this solution. But so the community is in the early stages. So we are a small but very engaged and very excited community, passionate about what we are doing. So it's a very good community to come in and if you want to get involved in open source software. I can tell you that it's surprisingly rewarding. You may think that, oh, it's more work for me. It's not really. It drives like this passion of producing something that didn't exist before. Like there is this drive of people helping. Like there is already, I think, 5 or 6 Java champions posted about this project, right? So it's getting traction. Like high level people in the Java community are looking into it, are liking it, are sharing it. Just today I was talking to a Java champion from Italy, and he was spreading this into the communities in Italy. So people are coming from all sides of the world and helping, right? So if you want to join, it's a great time to join. You can deploy it in non-critical applications where possible. Like I said, we have enough tests to tell you it's going to work fine in production for non-critical applications. What do I mean non-critical applications? Like I work for a bank, we move money. I cannot put this yet in an application that moves money, or that let's say it's an investment application that you need like throughput. Like we're not yet fully production ready, but the only thing preventing us from being production ready yet is more testing, right? So we need people to test, to come up. It's a beta version. We had two or three alpha versions before that we didn't advertise much, that they were very buggy, right? So we fixed all the bugs that we found. Like there is no major bugs reported. So but we still want people to test more, right? To grow the confidence that this is solid. And then we're going to release the version 1.0.0 non-beta, right? The production ready version. Sharing about OJP. That's something that sometimes people don't think about, that an open source project is not just about the code. The open source project is about all this that we're doing here, like sharing knowledge, and that can be a presentation like I'm doing right now. It can be articles, videos, like sharing on your social media. LinkedIn is an amazing tool to share these things, engaging with the community, right? Coming to our Discord, sharing your articles, sharing your videos. That's the way to help. Sometimes you don't have time to code, and you think like, oh, what's the point on liking a post or commenting a post or sharing a post? In the age of social networks, that's massive. Like that is massive. Like when one of these Java champions post about the project, if more people go there and like and comment like, oh, nice, I'm testing this project as well. It drives the attention, it drives the engagement. So it's very important. So buy us a coffee, right? There is a link there for money. If you want to put money in the project, please feel free. There is a button there to donate to the project. We would be very welcome. We use this money for paying for when we do these tests. There is servers in cloud that need to be paid. We do these T-shirts that we give to some of our contributors. So these kind of things, right? So we do need money as well. There is our Discord, LinkedIn, and X, my X. We don't have an X for the project yet, so that's my X there. And I think, yeah, that's very important. Yeah, I almost forget about it. So we have a contributor recognition program. So like you have Java champions, right? Like we have Java champions, we created our OJP champion. So what that means is if you contribute to the project, you get badges, right? So if we come here to documents and contributor badges, whenever you do something for the project that is seen, you get badges like this. And what does that mean? That means that you have proof, a written proof that you helped an open source project. And it doesn't need to be code, right? So the code is the blue line. So if you want to contribute code, that's amazing. We need people to contribute code. And there is levels, right? So if you contribute, let's say 1 PR, you're going to get your OJP contributor badge. If you contribute consistently with the project, for some time, and we see that you're constantly, reviewing PRs, leaving comments, trying to fix issues, you get a second level OJP developer then. And if you're contributing for a longer time, you get the OJP core developer. We have the same for testing and quality, right? You go from OJP tester to OJP quality advocate to OJP reliability engineer. Evangelism and community, right? So advocate, evangelist, community leader. So those are the levels. Documentation and content. If you're more like, oh, I don't like talking, and I don't feel confident to write code yet, but I can write an article. Like maybe you can do a test, write an article about it. Videos, social media content. You gonna grow in this lane here. All the lanes lead to OJP champion. You don't need to contribute just in one lane. If you contribute in more than one lane, that actually speeds up your path to get the ultimate badge, which is the OJP champion. And here's the rules, right? Like how it works. At the moment, I'm the one awarding all the badges. But once we have our first OJP champions, which we don't have yet, we're gonna have them awarding other badges, right? So whenever you get to an OJP champion, you're gonna be able to award these badges. So these are the people contributing to the project and engaging more with the community. Because if someone just do a PR in GitHub and never talk to us, I cannot award the badge, right? Because I don't have the contact of the person. But you can see that we have plenty of people here from mostly from Brazil, like I'm from Brazil, right? So it's normal that the community started with more Brazilians. There are 2 more people that will be awarded with second level badges now before the end of the year. I'm just holding the awards for closer to Christmas, right? So it's a Christmas present. So I think that's very cool. It's cool for people that are starting, right? And experienced people is a nice way to prove that you did something for the open source community, right? So you do something, you get a badge. The first level badges are easy to get. The other ones are harder. And, as you would expect. But the nice thing is that you can put these badges wherever you want, CVs, LinkedIn profiles, like you can use them as you wish. And there is a proof here. Your name shows in our Hall of Fame here. So I think that's a cool thing for people to look into.
That's actually nice. Just want to comment here. That's very interesting. I just have a one question there. Can a jack be awarded of a badge?
Jack?
A jack like Nicaragua Java user group?
That's a good question. It was not meant to be used like that, but I think it's a very nice idea. You just gave me a nice idea, Francisco. Let's think about that. What we can do, we can become partners, right? Like we can talk offline. Like the Java user group from Brazil is a partner. It's basically like what you guys are doing here, like helping the project to expand, giving access to community post, etc. Like we can talk about on those terms, but the badges for communities, like I think is a very good idea. Let me think about that and come back to you, Francisco.
Oh, yeah, sure.
The ones I showed, they're meant for people, right? You see that the names are, like titles for like people. But I think you just gave me a very good idea there. Let me process that. Guys, that's all I had prepared for today. I really appreciate the time and the space that the guys gave me here. It's a pleasure to talk to you. It's brilliant to see that people from Nicaragua are interested in the project. And again, engage, come to our Discord. Like we are very friendly community. Like there is no stupid questions in our community. We're very friendly and we like to have as many people as possible, many ideas. You see that Francisco just gave me an idea that I never thought about, and that happens all the time. I think you will grow a lot if you do things for the open source community. So don't lose the opportunity. Help us grow this project. If you believe in the project, support it the ways you can. It's volunteer work, right? We all have jobs, we have families, so. But you see that the guys here, the Francisco, I want to thank you very much for opening the space. Does this amazing work with the Java user group here there in Nicaragua. That kind of work is what keeps the open source community rolling, right? And it's amazing. Like it's people like this that keeps this ecosystem alive, right? So it's amazing. Thank you very much, Francisco, and the Java user group of Nicaragua. For the opportunity. It was a pleasure to be here. Thanks for the questions, the guys that sent questions. They were very interesting questions here, and I really appreciate it.
Yeah, thanks a lot to you, Rogelio. Honestly, this was a very, very good talk. There were a lot of good points there, good questions. I had a very good time listening to you and all the things that you have to share. So I wish you very good luck on sharing on the other jokes. I'm definitely gonna tell them to they should open if they have not yet talk to you and I'll see if we can keep sharing here in Latin America about your project. Do expect from me, I'm gonna read about it more and probably we'll do post something in the Java user group blog. We do have a blog there that probably will do something in Spanish. Other than that, yeah, no, again, thank you very much for being here and for sharing all this about your project. Also, before we go, I just wanna we were talking about Lombok and how that is something that you wanted to, did you like to do? And we do have some people in JDK Fundamentals, which is the group of jocks in Latin America. And we would like to have you there, maybe talk about it and have a small like discussion about it, and then we can, like share about what you do and how you do it, and if this is part of something that you use regularly, and that will be awesome.
Lovely, yeah. Let's set up a date. I don't know for now is the end of the year, but absolutely, let's talk in the background and
Yeah, I would like to introduce you to them. We can have a very nice chat. We have some Java champions from this end. And I don't know if you know the Colombian Java champions, they're there.
Mhm.
And we can talk about it, talk about your project, talk about other things, like a very friendly chat. And it will be awesome to have you there and share more with you.
Absolutely. Yeah. Let's do that.
Thank you very much, then. And I hope all of you have enjoyed this conversation and this talk that Rogerio brought to us. It was very, very good. And thank you and have a great day.
Thank you, guys. Have a great evening now, I belive, there
Evening.
in
All right.
Nicaragua.